right, next up is section 1.8, which is solving radical equations. So we have talked about simplifying radical expressions. Now, how do we solve them? So remember that radicals, we're working with square roots or nth roots and taking a look at how we are going to solve them. Now, we are going to take a look at 3 different types today. And the first one is, what do you do when you have a radical on both sides of the equation? These are the nice ones. So you can eliminate radicals by squaring or cubing or taking the 4th power to each side of the equation, and that's going to help us get a most likely a linear equation, but you might have a couple situations where you get a quadratic that you need to then solve for. The big thing here, though, is you do have to be careful because there are extraneous solutions. So remember back when we talked about our absolute value equations, some of our solutions did not work when we plugged them back in, and that is going to happen in this situation as well. So with that being said, I have the square root of 3x minus 20 on one side and the square root of 24 minus x on the other. What I can do here is we can go ahead and square both sides. That will knock out our square root, leaving us with 3x minus 20 is equal to 24 minus x. Look how nicely that worked out for us. So now you're just solving a linear equation. We're adding x, 4x minus 20 equals 24. Add 20, so 4x is equal to now 44, and we can divide, so x is going to equal 11. Now, if I do go back and check things out here, we are going to take, let's see, so 3 times 11, so that's 33. And when I take 33 and then we subtract 20 for that, that is going to be 13. So, oops, sorry, square root of 13 over on the left. And 24, subtract that 11, that's going to give us 13 as well. So we do get here that 11 is indeed going to be a solution for us. All right, number 2, I'm going to do the exact same thing here. I've got the square roots on both sides, so we're going to square both sides. That gives us 2k plus 24 is equal to negative 8 minus 2k. So get rid of those square roots for us. Go ahead, I'm going to add 2k, so that's 4k plus 24 equals negative 8, and subtract. So we're going to be negative 8, we're going to subtract 24, so that's negative 32. Negative 32 divided by 4 gives us negative 8, so k equals negative 8. So let's go back up and let's check and see how it works out for us. So we have 2 times a negative 8 plus 24, which gives us 8. So I get the square root of 8 over on the left. Negative 8 minus 2 times negative 8 gives me positive 8. So square root of 8 equals the square root of 8. That checks out. So negative 8 is going to be one of our solutions. Well, what about if you have a cubed root or a 4th root? Well, you're going to do the same thing. The only thing is that we're going to cube both sides, or we're going to take it to the 4th power on both sides. It doesn't change anything. Now you just have 2 minus 4a equals 2a minus 1. Here I've got 7m minus 23 equals 3m plus 17. All right, so why don't you go ahead and pause the video, see if you can go ahead and solve for those. All right, so for number 3, you should get 1/2, and for number 4, you should get 10. Now, if you do go back and check those answers, both of them do hold true, so we can move on from there. What happens if you have a single radical? So you only have one radical on one side. Then you can be a little careful. Very similar here to when you are working with absolute value. We isolate that absolute value. Here we are going to isolate the radical. So get the radical so that it is all by itself. then we can go ahead and get rid of it. So I have the square root of 6y minus 17 equals 5. Well, I can get rid of that if I go ahead and I square both sides. So 6y minus 17 will now equal 25. Now we can move on. So 6y, so 25, and I add 17 to that, so that's 42. And divide that by 6, and we get 7. So y equals 7. I take 6 times 7, and I subtract 17 from there, I get 25. And since the square root of 25 does equal 5, we are good, and 5 is our solution. Number 6, my radical is already isolated. I'm taking a cubed root, so that just means I need to take the cube of both sides. So 4 to the third power is 64. So 64 is equal to 1 minus 7c. So I'm going to subtract 1, so 63 equals negative 7c. And 63 divided by negative 7 would give us negative 9 for our value of c. So I go up and I say 1 minus 7 times a negative 9, which is 64. And then I take the cubed root of 64, and that is 4. So we are good with c being equal to negative 9. So 7 and 8, these are situations where you do not have that radical isolated. So to make that happen, I'm going to divide both sides here by negative 9. That will get rid of it for us. So now you have the square root of 4g plus 13. Now your radical is isolated. 45 divided by 9, so that's going to give me 5. And here's when you can square. So if I didn't do that, I would have to square the negative 9. This is just a way to avoid doing that. So 4g plus 13 would be equal to 25. And now you're just going to do the algebra. So 25 subtract 13, 4g is equal to 12, divide, g will equal 3. And if I go ahead, plug that in, 4 times 3, which is 12, and 13 to that is 25. Square root of 25 is 5. 5 times negative 9 is 45, so we are good to go. Number 8, here I am taking 5 plus the 4th root, so I'm going to subtract 5 from both sides. So now 2 is equal to the 4th root of w minus 11. So now I'm going to take it to the 4th power. So 2 to the 4th is 16. So 16 equals w minus 11. Add 11, so 27 is equal to w. So let's test that out real quick. 27 subtract 11, so that's 16. So if I take 5 plus the 4th root of 16, 4th root of 16 is 2. So 5 plus 2 is equal to 7. So we are good to go. So you might be saying, well, why every single situation here is working out for us? So why do we have to check for all these extraneous solutions when it seems to be working? Well, we're going to see some of those coming up here in these next few examples. Try and see if you can pause the video here and do number 9 on your own. All right, so number 9, you should get 13, and this one does check out if you go ahead and do that. So just notice you do have to isolate that radical and do 2 things. We got to add the 9 and divide by 2 before we take it to the 3rd power. All right, so number 10, well, here's a situation where not everything is always going to work out all dandy. Notice that your radical is isolated, so that is good news for us. We're going to go ahead, since I'm working with the square root, and we're going to square both sides. So that leaves us with 18 minus 7x equals x squared. Now, what this is creating for us is we now have a quadratic equation. So quadratic equations, involve us either factoring or completing the square, anything along those lines. And this one, it looks like I can factor it pretty easily. So I'm going to get everything equal to 0. So x squared plus 7x minus 18, we're going to set that equal to 0. So as far as factors wise here, we can do x plus 9 and then x minus 2. So x plus 9 could equal 0, x minus 2 could equal 0, and now we're going to go through and solve. Subtract 9, so x equals negative 9, and add 2, x equals 2. All right, so we go back up here. Now, when I go ahead here, and some of this you'll notice, you might be able to just look at your answers and figure out which one doesn't work. But if we take 18, minus 7 times negative 9, what I get here is I get 81. Now, square root of 81, does that equal x? In our case, x equals negative 9. Here, it does not. The square root of 81 equals a positive 9. So that tells us that negative 9 is not a solution. Now, if we go to 2, and I take 18 minus 7 times 2, so 18 minus essentially 14, which is 4, so square root of 4, does that equal x, which in our case is 2? And that it does. So here we have only one solution to it. Sorry, that's my puppy dog shaking her ears and readjusting for her sleeping. All right, let's take a look at 11, and let's do 11 together, and then I'm going to have you guys try and do 12 on your own. 11 is isolated, so I don't have to do anything there, but I can go ahead and square both sides. Now, as I square that left-hand side, though, I need to do p minus 7 times p minus 7. All right, so that involves us doing a little bit of FOILing. This is going to give us p squared minus 14p plus 49 equals 8p minus 63. And once again, now you have a quadratic situation that is being set up for us. So I'm going to bring everything over to the left-hand side. So p squared minus 22p, and then 49 plus 63, so that's 112 equals 0. So in this situation, you might look at it and say, okay, we can factor this out. Maybe you'd rather do completing the square. Let me just look at quick here as far as some factors. 28. What do I want to do here? I might do completing the square just so it makes it a little bit easier for me. Let's try other one here. Got a positive. And we're just slightly off here, so I'm just going to double check that I did 49, negative 14, 8p minus 63. All right, so in this situation, just because I'm not, and you guys might have found the factors, they're not popping off. Right here, by 1. I'm going to just do completing the square. So p squared minus 22p is equal to negative 112. So half of 22 is 11. 11 squared is 121. So I'm going to add 121 to both sides. See, I'm going to do this, and then I'm going to be like, oh, yeah, the factor would work. So we're going to do p minus 11 and p minus 11 equals negative 112 plus 121 is 9. Oh, yeah, it's definitely going to work out here. So p minus 11 squared is equal to 9. Now I can take the square root. So I have p minus 11 equals plus or minus 3. All right, so we're going to get that p is equal, sorry. So p minus 11 equals 3. P minus 11 equals negative 3. Add 11, so that's p is equal to 14. And add 11, so that's going to give us 8. Oh yeah, I was not trying those ones. All right, so 14 and 8 would be my solutions here. If I go up and I try them out, so 14 minus 7, so 14 minus 7, well, that's going to give us 7. And 8 times 14, and subtract 63 from that. That does give me 49. Square root of 49 is 7. So that one indeed does work. 8. 8 minus 7. Yeah, okay. 8 minus 7, that's going to give us 1. And then if I take 8 times 8, well, that's 64. 64 minus 3 is 1. Square root of 1 is 1. So here we get a situation where both of them are solutions. All right, so for number 12, I want you to try and do this one on your own. You are going to need to add an x to both sides right there. So square root of 2x plus 3 equals 2 plus x. So go ahead, pause it, see if you can do it. All right, so for number 12, you should get a solution of -1, and it does hold out to be true. All right, last but not least is what happens when you have rational exponents. Now, I know that when we were a while back, like I kind of had you guys passing on the rational exponents part of this, and actually, I think I'm just going to pass on it for now too. And we will get into this a little bit more when we get into our logarithms and stuff. So I am going to leave it there. To probably get you guys excited to think about that. So let's do those two types today. And as always, make sure you let me know if you got questions.